Hello Rene, we are going to present this homework, and this homework is number 6. My name is Estefania Toqueres. For this homework, we are going to use the program Benzene and click this program in our computer. And next step is read the problem. The problem you can see in this page, in this part. The problem have 6 questions. Okay, for this, click in Benzene and read the problem, and now click New Model, then in Settings, and the appropriate values. In this case, initial time is 0, final time is 1999, and time step is 20,000 theory. And modify these values in this part. Initial time, final time step, and in this part we are going to select a month. After this, in the toolbar at the top, we click on rate. On rate, you can see in this part, and place the first entry for emissions. Emissions, yearly methane emissions, and connect total methane emission gigagrams methane over year. You can see in this part. This is the first values you can put in this program. In this way, we begin to assemble the model and place all the variables as they are. The union of these variables is made by using the arrow tool. In this part, you can see the arrow tool, which allows used to put variables as total methane emission diagrams methane per year, and other variables is MCF, DOCF. These connect with the variable with the arrow tool. This is and connect in this form. We place the following key solid waste management variables, and something important is the shadow variable. Over time, the better estimate the results. The shadow variable is in this part. And next, connect this variable with yearly emissions of methane, kilograms methane over year, this form. The model is in this form in the first part. After adding the variables that we are going to use, the corresponding equations are added. For this, in the Benzene toolbar, we click on this part for the equations, and we add the equations for each variable, taking into account what do we want to determine at the end. The equations for all this part. And next, to add the first values on the input variable is solid waste management 1999. The value is 29.3. This value is put in this part in the equations corresponding. We add the value that a constant of 1 over k will have 0.05 in this part. The values that will go in the variables of a, b, c, d are provided in the following table, but when adding the equations, they are added in the form of a fraction, since in the table it's found as a percentage result. This value for a fraction we are going to put in this part in the variable a, in the variable b, in the the corresponding equation for COD T over gigagram solid waste. The equation is as follows: 0.4 multiplied for A class 17 multiplied for B class 15 multiplied for C and class 3 multiplying for D. This is the equation corresponding for COD gigagrams C over gigagram solid waste. The value corresponding to MCF is 0.6. You can see in this part. Then we have value of 0.77 in this part. You can see. And the value of the variable f is 0.5. For the variable L, this name, gigagrams methane over gigagram solid waste, this is COD multiply O for DOCF multiplying for factor F for 16 over 12. This is the corresponding equations for this part. And the other important equation is about yearly emissions of methane over year. This equation you can see in this part is very large and it's the most important equation because in this part you can see the time. In this case the time is 1999. For the questions you can modify in this part in the time. For the variable total emissions gigagrams methane over year, the equation is yearly emissions of methane gigagrams over year. The initial value is 0. And for the value, after placing the corresponding equations in each variable, we obtain the corresponding graph as seen in two images. In the first image, we observe the curve obtaining total methane emissions, and in the second image, we obtain the curve for yearly emissions of CH4. In this part, this is the curve total emissions, and in this part, this is the decreasing curve, yearly emissions of CH4 gigagrams CH4 per years. You can see these graphs after the put equations corresponding in our part. In the same way, we clicking on the left side after running the model, we obtain the corresponding value for each year as shown in the image. In this image you can see the values of emission gigagrams methane over year, the time 2021, 2022, 2000. This value you can see in this table. Now for the corresponding, the question 2. The question 2 determine the emissions of accumulated methane up to the years 2030 in gigagrams. We must run the model and read the amount of emissions for the year 2030. The values are as follows. You can see the values is corresponding 0.97 and the graph is in this form. You can see the graph is a graph increasing, and the table in this part you can see the value corresponding up to the year 2030 in gigagrams. Now for these questions more thoughts are added, so our model looks as follows. The question 3 say complete the model with the elements necessary for estimation of the corresponding CO2 emissions. For these questions, we are add more tool and design a new model, you can see add this part and add more variables. After adding more variables to the models for question 3, the corresponding equations are added as shown in this image. The equations for the CH4 is in this form 16 over 22, and in this form 44 over 22. The equations corresponding is, you can see in this part, modify in yearly CO2 emissions in this form and added this part. You can see the first part is only have these equations, and for this part we added these equations, the only values. The results are obtained as a growth curve for total CO2 emissions, and the values in the following table are also small. In this part, you can see the results for these questions, total emissions of CO2 emissions, and in this part you can see the table. In this year, the value is 2.67, and the curve you can see in this form. By modifying the model and adding more variables help us to read better. Question 4. What is the accumulated emissions of CO2 until 30,003 kilograms? The new model is in this form. The variables added is this part, and this part. We next to put the questions. The question is in this form, you can see is in this form, and click in the room in the program Benzene. You can obtain these results. These results in this year is 2.67. For question 6 and for question 5, it asks you about the emissions of CO2 and CH4 up to the years of 2030, but each kilograms of CO2 equivalent. We click on the variable where the amount of CO2 equivalent is found. Then we run the model, and with the help of the table and the graph, we can see the value for the indicated year. In the same way, in the table, you can see the different years in this case. You want to know only after a certain time and no longer since 1999. In the put flow, we change the time, and in this way, this time period will change. You can see this is the model, and this is the value correspond gigagrams of CO2 for this case equivalent. This is the result 25.09. Yes, and this is all, and you can modify the questions and put other years and modify in the yearly emissions of methane, gigagrams methane over years. In this part you can modify the equations and no longer since 1999. In the input flow we change the time, and this way the same period will change. Now, another situation, if there is a good disposal of the waste in the sanitary landfill, the CO2 emissions will not be in great quantity, since the waste management will have a better quality. However, if there is a large accumulation of waste, the amount of methane that will be emitted into the environment will be very large, and if they don't have any type of treatment, the emissions per year will change and the values will effectively rise. The values for a good treatment in the landfill would go down, but for a bad treatment, they could up with respect to the equivalent CO2 emissions, and in the future these values will change. And this is all. Thank you very much.